Let's take a look at exercise 19 from the text in section 9.4. This is actually problem 10 on this required section 9.4 homework. So we want to graph the parabola y equal x squared minus 4x plus 2. We want to find the intercepts. We want to sketch the parabola and the axis of symmetry. So we're thinking of the parabola as y equal ax squared plus bx plus c. A is an unwritten 1, always the coefficient of x squared. So this is really y equal 1x squared minus 4x plus 2. B is negative 4, and our c equals 2. So we are going to find the vertex, which we refer to as the point whose first coordinate is h and whose second coordinate is k. So we're going to find the vertex. H is found from the formula h equals negative b divided by the product 2a. So that's negative 4 divided by 2 times 1, which is 4 divided by 2, which is 2. I find k by replacing all of the x's in the parabola's formula with my h, which in this case is 2. So k is the y where x is 2. So k is 2 squared minus 4 times 2 plus 2. When I square 2, I get 4. Negative 4 times 2 is negative 8 plus 2. So 4 minus 8 is negative 4, and then I need to add 2 to that. So k is negative 2. The vertex is the point whose coordinates are 2, negative 2. So that is an ordered pair. All right, the axis of symmetry is the line, the vertical line whose equation is x equal h. In this case, that's x equal to 2, since our h was 2. A is 1, which is positive, so the parabola opens upward. I'm going to make a makeshift graph, plot the vertex, which is the point where x is 2 and y is negative 2. So from the origin, I move 2 units right and then 2 units down and make my point. So the parabola is going to open upward. So this makeshift graph allows me to see that this parabola does have x-intercepts. So it's worth taking a minute to find that out before doing the work to find the x-intercepts. If there aren't x-intercepts, when you find the x-intercepts by letting y equal to 0 and solving the resulting equation for x, if there aren't x-intercepts, your solutions are going to be non-real numbers. And you can save yourself time by making a makeshift graph and seeing if there are x-intercepts or not. I'm going to use the quadratic formula to find the x-intercepts. X is going to equal negative b plus or minus the square root of b squared minus 4ac divided by 2a. So I replace b with negative 4, a with 1, and the c with 2. And so I wind up with x equaling negative 4 is 4, plus or minus, when I square negative 4, I get 16. Negative 4 times 1 times 2 is negative 8. 2 times 1 in the denominator is 2. So I have 4 plus or minus the square root of 8, and that sum and difference is all over 2. I need to simplify the square root of 8 by writing it as the square root of 4, which is the largest perfect square that divides into 8, times the square root of 2. So this is square root of 8 simplifies to 2 square root of 2. So in my numerator, I have 4 plus or minus 2 square root of 2, and in my denominator, I have 2. So this is 4 divided by 2 plus or minus 2 square root of 2 over 2. So 2 divides into 4 twice. 2 divides into 2 square root of 2 times. So x is 2 plus or minus square root of 2. So those are my x-intercepts. The y-intercept is found by replacing x with 0. So when I replace ax squared plus bx, when I replace those x's with 0, I simply am going to get c. So the y-intercept is always whatever my c is. So I have the y-intercept, I have the x-intercepts, I have the axis of symmetry, and I have the vertex. So let's return to the problem. And let's put the x-intercepts in. 2 minus the square root of 2, comma, 2 plus the square root of 2. So those are my two x-intercepts. And the y-intercept is 2. Now I want to graph this. So I pick the vertical parabola tool, and I'm going to plot the vertex and one other point, and then the parabola will be determined. So I go to the origin, and I plot the point. I move 2 units right and 2 units down, and that's my vertex. And now I'm going to plot the y-intercept, y equal to 2. And I'm now going to plot my axis of symmetry. So I pick the line tool, pick dashing, plot any 2 points whose x-coordinates are 2. So I plotted 2, 14 and 2, 4. And that gives me the axis of symmetry. And we're finished.